Okay, so here we are on question number 8. We are in section 13.2. Very long section here. They want us to find the area of this hexagon. How are we going to find this hexagon's area? Well, basically, we're going to break it into triangles. If you just bring down this side right here and that side right there, then you've got a little triangle, you see. And we know the area formula for a triangle. It's a half times base times height. Right? Okay, and base and height. Remember, in a triangle, base and height, you know height has to go straight down to the ground. So do you see that the height is right here, and this down here is the base, right? So the height is that 3 root 3. That is the height. So this becomes a half times the base of 6 times the height of 3 root 3. So how do we work with that? Well, let's start. You can just use your calculator, or you can just multiply. Here, I'll just do it by hand. Half of 6. We know what half of 6 is. That's 3 times the other 3. That's 9 root 3. So that's the answer. 9 root 3. We just leave the square root of 3 sitting there. We don't do anything with it. And the units are square centimeters, because you know area is square units. Oh, wait a minute. I'm sorry. Nope, that's not the answer. We're not done yet. So it's 9. We're partly there. I forgot. That's the area. What I forgot is there's more than that one triangle. So that's the area of this triangle. Right? Again, we did half base times height. So that came out 9 root 3. But then how many of those triangles are there all the way around that object? If we make the other ones, you see there's a whole bunch of triangles, right? We just found the area of this triangle. That's 9 root 3. But 9 root 3, that's not the only one there. How many total triangles are there? Well, this is the first triangle, second, third, fourth, fifth, sixth. There's 6 triangles to fill that whole shape up. So that's going to be, I've got to take the, bring it up here, the 9 root 3 and multiply by 6, don't I? Because 9 root 3 was the area for one of those triangles, and there's 6 of them all together. Now, when you multiply with roots, I don't know if you remember from your earlier math days, you just multiply the whole numbers. Just leave the root separate. 6 times 9, 54, and then you just leave the root 3 sitting there. So that's the correct answer, 54 root 3 square centimeters. All right, now the second one will be much easier. The area of this triangle, it's just area is a half base times height, because it's just one triangle. It's not 6 triangles inside of a regular hexagon. It's just one triangle. Area is a half base times height. This is the base down here, and this is the height right here, which is 5 root 3. So it's going to be a half times the base, which is 10, times the height, which is 5 root 3. Half of 10 is 5, times 5 is 25 root 3. 25 root 3. And the units on that, square centimeters. There we go. All right. Number 9. Okay, so these are some of the activities we do in class. All right, so how do we find the area of this shape? Well, now first off, what they want is they want the area of the shaded. They want the area of the shaded region. So they want all this and this area. Just the shaded region, not the 2 circles in the middle, just the shaded region. They want the area of the shaded region. Well, how are we going to do that? Well, the shaded region, if you think about it, is the big circle area minus the 2 small circles, right? We've got the whole big circle here, right? There's the big circle. if we can find what's his area. Well, the area for any circle, the area formula for any circle is pi r squared. So what now the question is, though, what's the radius? Whenever we talk about r in the formula, for the area of a circle, the r is the radius. And what is the radius? Remember, that's middle to the edge of the big circle. Because radius, whenever you do radius, you go from the middle all the way to the edge over here. So that's the radius for the big circle, the whole big circle, from the middle to the edge of the big circle. So how far is that? Well, that looks like it's 8, doesn't it? Because it's 4 and 4. So that's got to be 8. So this is going to be pi times 8 squared minus 2 pi r squared, because it's 2 small circles. And the area of any circle is pi r squared, where now this r is a little different. This is the radius of the small circles, right? The radius of the small circles. So what's the radius of the small circle? From the middle to the edge. So that's the radius, just 4, isn't it? The radius is just 4 for the small circle. So this r will plug in as 4 squared. So we have pi 8 squared minus 2 times pi 4 squared. Because again, the area of a circle, any circle, is pi r squared. You just have to be clear what radius you're talking about. We've got the radius for the whole big circle here, which is 8. And we've got the radius for the little circle, which is 4. And we have 2 of those little circles. So it's pi 8 squared. What's pi 8 squared? Let me give room down here. This is going to become, bring this down, 64 pi, because 8 squared, 64, minus 4 squared is 16, and 2 times 16 is 32 pi. And so if you subtract those, the difference is 32 pi. 32 pi. And they want the units. The units on all these are going to be square centimeters, because that's what area units are. We're talking about how many squares can fill up that circle. 32 pi is the answer to that. Okay. Let's try part B here. Part B is going to be a half a circle added to a triangle, right? Because we want the shaded area, just the shaded area. So the shaded area would be a half a circle. So the shaded equals a half a circle plus a triangle. All right. So what's the half a circle? It's half of pi r squared. Right? Because again, a circle, the area of a circle is always pi r squared, and we have here half a circle. So it's 1/2 pi r squared. So it's 1/2 pi. What's the radius? Remember what r? R is always radius. Radius is middle to edge. So if you take this small circle from the middle of this of this half circle to the edge of this half circle, there's the radius. The radius must be the 1 there. So that's a half pi. 1 squared is just 1. This is just half a pi. Plus, and now we got to do the triangle. What's the area of a triangle? A half times base times height for any triangle. So then for this triangle, this shaded triangle over here, remember base and height are at 90 degrees to each other. So this has got to be the height, which is 2. And this is the base here, which must be 1, just like the other side's 1. Base and height, they're 1. So the base is 1, and the height is 2. So we're going to add these together. So that's a half times 1 is a half times 2. Half of 2 is 1. So the answer is half a pi plus 1. They want us just to leave it that way, and it's square centimeters. Square. And that's also, by the way, the same as saying pi over 2 plus 1. You know, that's exactly the same thing. There's no difference between saying half a pi and pi divided by 2, right? Because half of something is it divided by 2. Either way, you can say it either way. So it's half a pi plus 1 or pi over 2 plus 1, same thing. That's the area, square centimeters. Now for part C, that's kind of tricky. Again, we're figuring out the shaded area. In fact, actually, let me do this. Let me put this up here. So the shaded area, notice the shaded area is exactly half of that circle. It's half of the circle. It's weird shading, but it's half the circle. So it's half of the area of the circle. What's the area of any circle? Well, it's half of the circle area. So it's half of pi r squared. So it's a half of pi. Now what's r? What's r? R is the radius. Remember, radius is middle to the edge. That's what radius always is. So from the middle to the edge, there's the radius. What does the radius look like it is? If this is 1 and this is 1, the whole radius must be 2, huh? So 2 squared. Like that. So that's going to be a half of pi times 4. Half of 4? 2. 2 pi. So 2 pi is the area. And again, that's square centimeters. Okay. Well, I wanted to save a whole bunch of room for crazy part D. D's really pretty tricky here. On that one, part D. So how are we going to do part D? Well, what I'm going to do is I'm going to just like fill this in at first. I'm going to say, well, can I figure out the area? Let me do this. That wasn't so good. Yeah, I need a lot of room here. Okay, let me do this. Can I figure out the area? Put this right in the middle here of. Can I figure out this area? Like this. I'm going to fill in this. This is. I'm going to fill in both these guys for a minute. I'm doing it because I have a plan. Well, it'll make sense, I think. So if I fill these in, then we have what is that? The shade. So I'm going to start by figuring out something different than they want. So the shaded area here, this shaded area and this shaded area. The shaded areas are 2 half circles, which equals 1 whole circle, doesn't it? 2 shaded half circles is 1 whole circle. And what's the area of 1 whole circle? Pi r squared. Pi r squared. So, okay, pi r squared. What's the radius? What's the radius of it? So remember, radius is from the middle to the edge. Right, from the middle to the edge. Well, remember, see this 20 here? So it's 20 all the way. So this must be, this radius here, this radius must be 10. From the middle to the edge, radius must be 10. So that's pi times 10 squared. 10 times 10 is 100. So 100 pi. So 100 pi is what? It's the shaded areas must make 100 pi, right? Okay, so what? What does that mean? Well, that's just my first step. Now what I want to find is I want to find this blue area that's not shaded. So the not shaded blue areas. How are we going to find the not shaded blue areas? Well, they've got to be the area of the whole square minus the two shaded half circles. Are you tracking with me on that? That I'm hoping makes sense to you. We're taking the area of the whole square. So if I think about this whole square here, the area of the whole square, and then subtract the two shaded half circles, the two, red shaded half circles. The difference is going to be those two blue areas, the not shaded blue areas, the two let's do it that way. The two not shaded blue areas must be the whole square. It's the whole square, area of the whole square, take away the two red shaded half circles. The difference will be those two blue not shaded areas. So what's that? Well, the area of the whole square, area of the square is length times width, minus, and we've already got this over here. This is 100 pi, right? We just found it right here, right? The shaded areas, the two half circles came out 100 pi. So the two shaded half circles is 100 pi. This is length times width, which is what? 20 times 20, right? Because the whole square is 20 by 20. So what's that going to be then? That's going to be 400. 2 times 2 is 4, and then throw the 2 zeros in the back, minus 100 pi. 400 minus 100 pi, that will give me the area of two not shaded blue areas. So let's be super clear on this. So, two not shaded blue areas is 400 minus 100 pi. So getting back to our main diagram, we're almost there. Getting back to our main diagram. So we're talking about this area and this area. Those two blue not shaded areas. Well, where's that on the original diagram? That's right here and right here, right? I just found that's the 400 minus 100 pi. That's those two zones. Those two zones, 1 and 2, is 1 and 2 there, isn't it? I just found them. The two not shaded blue areas must be 400 minus 100 pi. By the way, you can't make that 300 pi. You can't subtract those because those are unlike terms. It's kind of like from algebra when you had 400 minus 100x. You can't subtract them. If the first one had an x, if they both had x's, then you could subtract them. If those both had pi's, if the 400 had a pi also, then we could subtract them and get 300 pi, but the 400 doesn't have a pi, so you have to leave it just as it is. So anyway, so at this point, we have area 1 and area 2, right? The two not shaded blue areas, this area and this area, which is the same as this area and this area, is 400 minus 100 pi. Now, we just do that again because we have 3 and 4. We have two more of the same areas. So I'm going to say all 4 not shaded. Well, here, let me change the color, make it more clear. So all 4 not shaded areas equal what? It's going to be 400 minus 100 pi add another 400 minus 100 pi, right? Because two of them, we already said two of them, like these two, make 400 minus 100 pi. So these two make 400 minus 100 pi, and these two are the same, so they make another 400 minus 100 pi. So that adds up to be 800 minus 200 pi. So that's all four not shaded areas. That's all four not shaded areas. Finally, we're almost there. Last step to get, we want to get the four leaves, right? That's been our goal all along, is to find the area of those four leaves. What's it going to be? The four shaded leaves is going to equal the area of the whole square minus all four not shaded. Not shaded areas. It's the whole square. This entire square. Subtract out the 1, 2, 3, and 4 not shaded areas. Take those out, you're left with the four leaves. So what's the area of the whole square? Well, it's a square, so it's 20 by 20 by 20, right? This is 20 here by 20 here. So it's 20 by 20. Area of a square is just length times width, one side times the other, 20 times 20, minus, what's all four not shaded areas? All four not shaded areas is this. You got to put parentheses around that because you're subtracting the whole thing. Like that. And so, can we simplify that a little bit? That'll be 400. Now, what do you do with a minus in front of parentheses? Distribute. Minus 800 plus 200 pi. It changes both the signs, right? When a minus is in front of parentheses, it distributes and changes all the signs. Because we had to subtract this whole 800 minus 200 pi right here. We had to subtract that whole thing, all four not shaded areas. All right, 400 minus 800 is minus 400 plus 200 pi. There it is, square centimeters. That was a challenging problem. Honestly, I'm not going to put anything that hard on the test. Maybe I would for extra credit, but not for regular credit. That was too hard. Okay, number 10. A circular flower bed is 20 meters in diameter and has a circular sidewalk around it 3 meters wide. Find the area of the sidewalk in square meters. Okay, what are they talking about? Well, what they're saying, see, we have room there, yeah. So what they're saying on this one is that we have this circular sidewalk, or we have this circular flower bed. So this is the flower bed. But then around it, we've got like a cement walkway, you know, all the way around. I'm not drawing this so well, but all the way around the flower bed. So you got a circular flower bed, and then you got this walkway that goes all the way around it. Now, it says that the diameter of the circular flower bed is 20 meters. Remember what diameter is all the way across. So that's 20. So you know what we really care about, though. For all the area formulas for circles, we need radius. So that means let's just change it to be halfway. If 20 is all the way across, then 10 must be halfway across. The radius must be 10, right? Diameter 20 means radius 10. And what is the width? The width right here of the walkway is 3, isn't it? I can make that a little bit better. So that's going to be 3. there to there is 3. Okay, so, and what do they want us to figure out? They want us to figure out the area, like how much like cement area is the walkway all the way around. Like if you're pouring cement, if you were the contractor pouring cement, this is what engineers figure out and people like that. They need to pour cement, a cement walkway around the flower bed, a 3 foot wide or 3 meter wide path all the way around. How much area is that? How much total concrete is all that? How are we going to figure that out? So the shaded blue area, that's what we're trying to figure out, the walkway, that's going to be the big circle minus the inner circle. Do you see that? Or we can, instead of big, we call it outer. The outer circle minus the inner circle. So this outer circle, if we find out all his area, and then we subtract the inner circle, it's like a donut. We subtract the whole out of the middle. What will be left is this shaded blue area. So that's the plan. So what's the outer circle? Well, it's pi r squared, because it's a circle, area of a circle is that. And what's the inner? It's also pi r squared, but they have different radiuses, radii they call them, don't they? There's the outer radius. Here, let me give a little more room. It's going to be pi. What's the outer radius for the outer circle? From the middle to the edge of the outer circle, that must be 13. 10 and 3. From the middle to the outer edge must be 13. So pi times 13 squared. Inner circle, it's just 10. From the middle to the edge of the inner circle is just 10. So if you multiply that in your calculator, 13 squared is 169 pi minus 10 squared there is 100 pi. That difference is 69 pi. There we go. Let's go on to number 11. The area of a square is 196 square centimeters. What is its perimeter? That's an interesting question. So we have a square. And the area is 196. Well, what's the formula for the area of a square? Length times width. And really, length and width on a square, they're both L. Or you could call them both X, how about? They're both the same, because it's a square, right? The length and width are the same. So length times width is really X times X. In other words, it's X squared. Remember that from algebra? X times X is X squared. And so we can actually solve this little equation here for X. How do we make that into just regular X? How do we get rid of that little square there so we can find out what just regular X is? Well, we do a square root on both sides. If you remember from your earlier math courses, the square root is the opposite of the square. So we do that, and then you hit the square root button on your calculator, square root button here. This will come out 14. So X is 14. So that means this square is 14 by 14. Okay. What's their actual question now? They say, what's the perimeter? The perimeter. Perimeter means all the way around the edge, right? It means this side plus this side plus this side plus this side. All four sides, the perimeter, the edges, all added up. Well, we know this side's 14, this side's 14, the other side must be 14, and this must be 14. So the perimeter must be 14 plus 14 plus 14 plus 14, and that comes out to be 56. And what are the units on that? That's actually just normal centimeters. It's not square centimeters. Why not? Because it's just length around the edge. Length around the edge. So I'm just doing this edge, this edge, this edge, and this edge. It's just straight length. It's not area. I'm not filling up the middle. I started with the area formula, and I eventually found that the edge was 14, and then 4 edges make the outside, which is 56 centimeters, because now we're just adding up the 4 edges, not the area in the middle. That's perimeter. Part B, coming on down here, part B says the area, so they say the perimeter of a square is 32. So saying, okay, we've got some kind of square, and the 4 sides, perimeter, is 32. How can we find the area? Well, if we know the perimeter is 32, this is x, 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 x. It's a square. All the sides are the same. So that would mean those x's added up, those 4 x's added up, must equal 32. Because perimeter is all the way around the outside. So all the way around the outside, that's 4x is 32. How do we solve for x there? Divide by 4. X is 8. So we get x is 8. So the sides are all 8. This is 8, 8, 8, 8. And now that we know that, we can answer their final question. What's the area? What's the space in the middle? Area. Area of a rectangle. So we got perimeter of a rectangle is just add up the outsides. That's just the edges. Area is space in the middle. That's length times width. Let me move it over here. That's just length times width. And so that equals 8 times 8. It's just one side times the other side. That's how we find area in the middle. It's just one side times the other side. As opposed to the edge, you add up all 4 sides. At the perimeter, we added up all 4 sides. But area, we multiply just one side by the other. That comes out 64. And what are the units on that? It's going to be square centimeters. 64 square centimeters. Because, again, we're talking how many actual squares to fill up the area, which is different than perimeter, which is just around the edge. That's just straight centimeters. But area in the middle is how many squares, centimeter by centimeter, to fill it up. There we go. Now, number 12. So now we're going to go into these problems in which we do these dot matrix things. These are helpful to help us think about area. So what we're going to do is think about making triangles. I think we can do all of these with just triangles and rectangles, things like that. So let's try it. So this is a triangle, and the area of a triangle is a half times base times height. So this is the base, and this must be the height. This must be the height. Because base and height have to be at 90-degree angles. This is a right angle there. At 90-degree angles to each other, because that's what height means, doesn't it? Height means straight down to the ground. So height has to be at 90 degrees. So what is that height? It's 1 square, 2 squares. It's 2 squares high and 1, 2, 3 squares wide. The base is 3. So the base is 3, The height is 2. Base is 3. I put it there. Height is 2. So it's a half times the base, which is 3, times the height, which is 2. 3 times 2 is 6. Half of 6? 3. So what does that mean? That means there's exactly 3 squares. It's 3 squares. You don't have to write down the units or anything. But that's the answer. It's exactly 3 squares that fill up that shape. What do I mean? I mean, if you talk to actual squares here, here's 1 square. Here's half a square. Right? This is 1 square. This is half a square. This is another half a square right there, isn't it? It's exactly half of a whole square. So that's 1, a half, that's 2. And this must be 1 square exactly, is it? Yeah, because see how, this is another way we could have just done this problem. See how if I did this, what is this whole red section there? That's 2 squares, isn't it? See, there's 1, 2 squares. And the blue is exactly half of that. So it's half of 2. It's half of 2, so it must be 1. So there's another way. Maybe that's an easier way to see it. There's 1, 2, and then 2 halves makes 3. There's exactly 3 squares that fill up that triangle. Let's look at number 13 in the same way down here. It's a triangle. And so the area of a triangle is a half times base times height. So the base is right there. And the base must be how many? So it's 1 square, 2 squares. The base is 2. Now where's the height? Height has to be straight down to the base. So this is height here, isn't it? From here to here. That's the height. And it's 1, 2 as well. See how height has to come straight down to the base. Has to be at 90 degrees. There has to be a 90-degree angle right there as height hits base. You know, the extension of the base hitting the height. So the base and the height have to be at 90 degrees. That's what height means. You measure your height by going straight down to the ground. So height is 2, base is 2. So it's a half, base is 2, height is 2. So 2 times 2 is 4. Half of 4 is 2. So what that means is exactly 2 squares fit into that object, kind of squished. Where that means like 1, 2. So this area is exactly the same as the area of that triangle, for example. Exactly 2 squares fit inside that triangle. It's kind of hard to see it because it's squished and pulled to the side, but that's what that means. Exactly 2 squares is the space, the area inside that triangle. Okay, let's, I already kind of did something on this one. Let's go through that again and this one as well. All right, so let's go through 14 and 15 here. For 14, I think it's best, let's just try breaking it into squares. There's 1 square. There's 2 squares. There's 3 squares. This is 0.5, half a square. This right here is 0.5. It's half of a whole square. Okay. And now, what is that? That's all we got left. So right now we have, I shouldn't have made these 2 and 3. Just make them 1. That's 1 square, 1 square, 1 square. Half a square, half a square. There we go. So 1 plus 1 plus 1 plus 0.5 plus 0.5. And then what's the little green area there? Well, if we did the whole, what would that be? Altogether, that would be 2 boxes, wouldn't it? That's 2 squares. And you see the blue is half of that? So this must be 1. It's half of the 2. 1. So what do those have to be? 1, 2, 3, 4, and then this makes one more. 5. Means there's 5 squares that fill up that shaded area. Let's see if we can do the same thing down here on number 15. So number 15, we have a square there, a square there. Here's half a square. Okay, what? Oh, we put that line there. That's half a square, isn't it? And then what is this going to be? Can you see it's half of those 2 squares, isn't it? It's half of those 2 squares. So it is 1 square, really. So we have 1 plus 1 plus 1 plus 0.5 plus 0.5 plus 0.5. 1, 1, 1, 0.5, 0.5, 0.5. What's that? 3, 4.5. 4.5 squares fill up that area. 4.5 squares. Okay, number 16. Yeah, here I'd already done it. Let me redo it with you. So number 16 and 17 are more tricky. We're going to have to do those by subtraction. Yeah, the reason 16 and 17 are more tricky, more advanced, is because it's too hard to find the area straight. Like the area of this shaded region is so weird. You know, like if you say, well, I'll just do what I did before. I'll just break it into like we could do some of it, I guess. Like if we could say, I'll break that right there. Yeah, you could figure that out. That's got to be 1 right there because it's half of this 2. So that's got to be 1. We could do that, but then where are we going to go from there? How are we gonna figure this weird shape out? You can't tell, like, how wide is this? It goes from 1 dot to another dot and then like part way. I don't know, what is that? How far is that? Can't really tell. Can't tell. So this is such a weird shape that we really want to do it by subtraction. So let's do this. Let's just box this area in. Okay. And let's figure out what's missing. Let's figure it out by figuring what's missing. Like, here we go. I'll say 1 is missing there. Let me see here. I'll go down here. Maybe I better not. Hold on. How about if I do this? That'd be better, huh? 1, 1. And then, let's see. This right here, if I was to put this up there, that'd be 2 whole squares. So what's missing must be 1. Remember, I'm doing what's not shaded. I'm going to calculate what's not shaded. Okay. Oh, and I better take out this 1. It'd be easier just to do this whole triangle here. Just this whole triangle. What's the area of that whole triangle? Well, it goes from here to here, which is what? 1, 2, 3. So it's 3. That's the height of 3. And here the base, 1, 2. The base of 2. It's a 2 by 3 triangle. So it's a 2 by 3 triangle. 2 times 3 is 6. But remember, area of a triangle is a half times base times height. So it's a half of 2 times 3. It's a half of 2 times 3. The base is 2, the height is 3. Half of 2. 2 times 3 is 6. Half of 6 is 3. So this must be 3. Let's do the same thing right here. Area of a triangle, half base times height. So this is the height which is 2. This is the base, which is 3. Same thing. So it's a half of 3 times 2. 3 times 2 is 6. Half of 6 is 3. So this is also, so this is 3. This is also 3. Get rid of that there. So, okay, so I'm finding what's missing. Finding what's missing. So what's missing? Missing is 3, 3, 1, 1, 1. See how we figured that out? So that adds up to be 6, 7, 8, 9. So 9 is missing. 9 is missing. Oh, well, actually, and then I could just throw in these down here as well. Boom, boom, boom. Boom, 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 boom. So plus 4. So 13. So the whole bottom row is missing. And then all that other stuff. So there's 13 total squares that are not shaded. 13 total squares that are not shaded. We counted what is not shaded. 13 total squares that are not shaded. Okay, so now, how big is the whole array? The whole thing is how many tall? It's 1, 2, 3, 4 by, and what is it? Or I'll do it on the bottom here. How far across is it? Same thing, right? 1, 2, 3, 4. It's a 4 by 4. So the whole rectangle or square, it's a square, isn't it? The whole square is 4 by 4. So there's 16 squares all together. That makes sense, right? I'll do it down here. If you just do all the squares, if we just filled in every line and counted all the squares for this diagram or any of them, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. There's 16 total squares. Whole square, 16, and 13 of them are missing, not shaded. So the shaded must be the 16 total squares that are there minus the 13 that are not shaded. That must mean exactly 3 are shaded. That was pretty challenging. We counted all the ones that were not shaded. That came out 13. And subtracted that from 16, the total area of the whole thing. So that means there must be 3 that are shaded. So right in here, this must be the shaded zone, must be exactly 3 squares squished into that weird shape. Isn't that strange? All right, last one, number 17. Let's try it. So I'm going to do the same thing. I'm going to count what's missing. So I'm going to make a triangle here and some squares here. 1, 1. Triangle here. This is a tricky one, isn't it? This little weird, I'll get to that one later. I'm going to do this triangle here. Okay, let's do all those. Then we'll do that weird triangle in a minute. Okay, so this is a triangle. It's a half base times height. So it's what? What is its base and height? It's 1, 2, 3 by 1. So it's a half of 3 times 1. Half of $3 is $1.50, right? Half, 3 times 1 is 3, and half of 3 is $1.50. So this must be 1.5. The area of that triangle must be 1.5. So area of this triangle, half base times height. this from here to here must be 2. Here to here must be 1. So half of 2 times 1. Half of 2 is 1. This must be 1. This is 2. From here to here is what? 1, 2, 3, 4. So the area here, let me bring it down here. The area here must be a half of 4 times 2. Half of 4 times 2. Half of 4 times 2 is 8. Half of 8, 4. So this must be 4 in here. Kind of get rid of some of these things. So this must be 4. 1.5, 1, 1, 1. And now, finally, for that weird little triangle in the middle. This little triangle here, if you look at him sideways, let's call this his base, then what would his height be? His height would be from the tip top straight down to the base. That would be his height. Do you see that? It's kind of confusing. So, for this little triangle here, his base, he's on his side. He's sitting sideways. This is his base, which is 1 square wide, and his height is 3, because it's from the tip top straight down to the base, to the extension of the base, that is, right, at 90 degrees. So the base is only 1, the height is 3. So the area is a half base times height for that little triangle there. It's a half. Base is 1. Height is 3. Right, this is 3 units height. Half of 1 times half of 3 is $1.50. So this must be 1.5. Okay, so we figured out all the areas that are missing. So let's total the missing. What are all the not shaded? So the not shaded areas, let's add them up carefully. We've got 1, 1, 1, 1.5, 1.5, 4. 1.5, 1.5, 4. 1.5, 1.5, 4. Add those up. What's that? 3. And this is 3. You know, $1.50 and $1.50 is 3. 3 and 3 is 6. And 4 is 10. Not shaded is 10. There must be 10 total squares not shaded. So then shaded must be 16 minus 10. Because again, there's 16 total squares in these diagrams. Minus the 10 that are not shaded equals 6. Exactly 6 squares must be shaded in that weird shaded figure. There we go.